Biofuel for energy need and food security. Biofuel is a type of renewable energy source derived from microbial, plant, or animal materials. A renewable energy source means the one which can be replaced by natural process. Generally, food, fiber, and wood process residues, energy crops, agriculture waste, residues from forest sector are used to generate electricity, heat, combined heat and power, and other source of bioenergy. As the name suggests, biofuel means use of biotic components of the environment to generate fuel. This is the classification of biofuel sources by different characteristics. The main sources are from woody biomass, herbaceous biomass, biomass from fruit and seed. Biomass means organic matter that can be used as a fuel. How woody biomass can be a potential source of biofuel? The biofuel derived from woody biomass are wood fuel. The forest tree and plantation tree can contribute to wood fuel as the cellulose in wood can be extracted and converted to biofuel. And the grass, cereal crop and grain can contribute to agrofuel. The direct byproduct of wood industry are thinning byproduct, logging byproduct. Thinning is the selective removal of trees to improve growth rate of remaining trees. Logging is the harvesting, cutting down of trees and sowing them. The indirect byproduct are wood processing industries byproduct and black liquor. Black liquor is an important organic byproduct of pulp and paper production, can be gasified and then combusted in a turbine to generate electricity. Also, straw shell husk are the direct byproduct of herbaceous biomass. They can contribute to agrofuel. How? Coconut shell has a high calorific value. It can be used to produce steam, energy rich gases, bio oil, biochar, etc. And coconut husk, the direct combustion of coconut husk can be used to generate charcoal. It can be transformed into a value added fuel source and it can replace wood and other traditional fuel source. Also, other municipality byproducts such as kitchen waste, sewage waste also can be a potential source of biofuel. This is another classification of biofuel. Broadly, they are classified as primary biofuel and secondary biofuel. Primary biofuel include firewood, wood chip, pellet, animal waste, and so on. Secondary biofuel are again classified into three: first generation, second generation, and third generation. First generation biofuel is obtained from seeds, grain, or sugar, and it includes bioethanol or biobutanol by fermentation of starch or sugar, biodiesel by transesterification of plant oil. We will see in the coming slide about biodiesel and transesterification. Then second generation biofuel are obtained from lignocellulosic biomass. Examples include bioethanol or butanol by enzymatic hydrolysis, methanol, Fischer-Tropsch gasoline and diesel, etc. Third generation biofuel are obtained from algae, seaweed, and its example include biodiesel from algae, hydrogen from green algae and microbes. Next is about biodiesel. Biodiesel is mainly produced by combining vegetable oil or animal fat with an alcohol and a catalyst through a chemical process known as transesterification. Transesterification is a chemical reaction used to convert triglycerides contained in oil into usable biodiesel. That is an reaction of an ester with the alcohol to replace the alkoxy group of the ester, OR, of the RC double bond or OR group. It is used for production of biodiesel. Oil for biodiesel production is taken out from almost any oilseed crop. The most popular sources are rapeseed, soya bean. Then in subtropical countries, sources are coconut, palm, jatropha. Then small amount of animal fat, fish and animal processing operations are also used for biodiesel production. Depending on the source, they display a greater variety of physical properties such as viscosity and combustibility than ethanol. Biodiesel can be mixed with the traditional diesel fuel or it can be burned in its pure form in combustion ignition engine. Energy content of this mixture is 95% of that of diesel, but it advances the lubricity of diesel and increases the cetane value. Cetane is a powerful energy compound that improves the ignition quality of fuel. Then biodiesel is high in oxygen content which helps in the completion of fuel combustion, reducing emissions of particulate air pollutants, carbon monoxide and hydrocarbon. It also contains only a negligible amount of sulfur, thus reducing sulfur oxide emission from vehicles. These, to put in a nutshell, the advantages of biodiesel over conventional diesels are: biodiesel has higher lubricity. It is more slippery than petroleum diesel. Then biodiesel contain practically no sulfur. That is a good thing because it can be expected to result in reduced pollution from engine which uses biodiesel as fuel. Then it has higher oxygen content, about 10 to 12 percentage more than petroleum. These are the advantages of biodiesel over conventional diesel. Next is biofuel demand and how biofuel demand is affecting the food resources. How is it competing with the food resources? Biofuel demand is increasing because of a combination of growing energy needs, rising oil cost, the pursuit of clean renewable source of energy, and the desire to boost farm income in developed country. But on the other side, the need for crops such as maize and sugarcane, which are used as the major feedstock for biofuel. Feedstock means starting material used to make biofuel, such as corn, maize, sugarcane, etc. The these feedstock for biofuel has increased dramatically. This demand has had a significant and increasing impact on global food system. Effect of growing biofuel demand go hand in hand with tightening grain markets, and it reflects the improved dietary style of people. In developing countries, people are showing a diet preference of staple crops and higher value products like meat and dairy. And as a result, the demand for grain and protein based animal feed is increasing, or it can be said as skyrocketing. These changes have led to increasing pressure on global agricultural market and higher food cost. The poor people in both rural and urban areas are disproportionately vulnerable to these forces because they spend a large share of their income on food. Biofuel production will definitely affect world agricultural commodity prices and food security. Even though biofuel production have a negative impact on food security, it can also generate opportunity for agricultural development. An example is that if biofuel crops are grown on unused land without using any fertilizer and additional labor, the additional cost of food production is unaffected. In some cases, the production of biofuel will seriously compete for these resources, and this will definitely affect the cost of food production on the other hand. For example, Jatropha generates larger quantities of oil and hence more biodiesel if it is grown with more water. Hence, production of biodiesel from Jatropha grown on marginal land means the land which has no agricultural or industrial value. When the production of biodiesel from Jatropha grown on marginal previously unused land without using any fertilizer, it will have an adverse impact on food security if it competes for scarce water resources that are used by agricultural activities. One more advantage of the biofuel feedstock production is that the higher prices for commodities resulting from biofuel feedstock production can mean higher income for some farmers in developing countries and better agricultural wages for laborers. But it could increase the pressure on fragile natural resources on which poor farmers depend, and it potentially degrade land and stress on other limited water supply. Over the coming decades, global food and agricultural system not only continue to come under the strain of providing for the competing need of food, feed and fuel, it will also face greater pressure from climatic and other economic changes. So these are the ways in which biofuel demand competes with the food security or food resources. Thank you.